Is there, you can see or off? Okay. I can self live stream. Good. If that self. All right. How about now? Okay, that's good. So, welcome back to lecture number 1, if the first one was 0. And let's see if we can get things working this time. And just for your knowledge, I've uploaded these slides to the Slack channel, so they are there for you. If you want to, I can add them to the Moodle page also, but just give me a note on that. And this is my first announcement. I made a sort of a schedule mistake here. I have misinterpreted the entire schedule, and I have a solution for it, but I will need your help for the rest of the course. And this is my schedule. So we're at the 7th of November today, and this is a broadcasting that everybody can have a look at, and anyone who wants can come here. But if you look on the 13th and 14th, lecture number 2 is set for 1DV513, and lecture number 3 is set for 2DV513. Now that's my mistake here, because I thought that I had a pool of lecture and I could do whatever I felt like with those. That was not the case. You were divided into those two branches I was talking about at the first lecture. So what I need some help with is this. On the 13th, which is on Monday, I think, those who can attend that here at school is 1DV513. Those who are attending the 2DV course can have a look at it afterhand. Have a look at the recorded lecture. And the same goes for lecture number 3, where if you are attending 2DV513, then you can be here having a look at me live. But those who are attending 1DV513 need to look at it on YouTube, on the recording. So that is my solution for it. Some of the lectures will be live. You can go here physically, and some of them you will need to have a look at YouTube. And that is my That's my solution. That's the best option I can come up with. The good thing, hang on a second, the good thing here is that I can actually add more lectures. So if we need to talk about a specific topic, then we can add one. Right, yeah?
Why can't we attend both lectures? I mean, like, is it because of like room capacity that's limited?
No, that's not a problem. I think that some of you are attending different courses. So let's say the lecture on the 13th, which is for 1DV513, I sort of assume that those of you who are attending the 2DV course weren't able to come here on Monday. So that was my sort of solution for it. But if
half the time we can go to both lectures.
yes, so if you can, if you have the possibility to attend the lecture here physically, please come. And if you can't, have a look at it on YouTube. I hope that it doesn't present any troubles for you. Is that something that makes you feel uncomfortable in here, doing the lecture this way? No? Okay, that's great.
A question. You said that we should look at the lectures, like, because for the 2DV course, it's a different requirement, right?
No,
Than for 1DV.
last year these two courses were sort of divided after 4 or 5 lectures into 2 different branches. This year that won't happen. It will be the same course. So it doesn't depend on which one you're attending, 1DV or 2DV, it's the same course.
Okay.
So that was a decision made by the previous lecturers, where they felt that you didn't gain anything from having separate forks of it.
But they are on 2 different levels, right?
No, they are just 2 different years. So 1DV is a first year, and the 2DV is just a second year, but they are both a sort of a, if I may use the word, a beginner's course in terms of database management systems. So because I had the same question that you had, but no, that's not the case. So all the lectures here will be live as well. So it doesn't matter whether you sit here or not, it will be live. So you can have a look at it afterwards. Okay. And I'm very sorry for that. It's on my account. And I also had a short session with Maria, and she told me that these are the 2 weekly meeting dates or meeting times for tutoring, Mondays and Tuesdays. And that goes for those of you who are remote students or are not remote students. It doesn't matter. And if she feels that those 2 times is not enough, she will add a bit more of it. Is that okay? Right, so back to that database management system thing. So I assume that you have used a database before, and I'm quite sure that you have, but you might not have been aware of it, because when you are, let's say, surfing into a web page, you are most likely indirectly talking to a database. You could easily create one by yourselves. It would be quite easy to create it, but it wouldn't be very efficient. And after a while, it would grow to become a very complex system. So it is better off buying one or download a free one using the open source movement. such as MariaDB or MySQL, or any other of those database management systems out there. There are some NoSQL ones like MongoDB. But the thing with a database management system is that it handles very large sets of data. And when we're talking about very large, it means easily over gigabytes. We're not talking megabytes there, we're talking gigabytes and even terabytes. And for those cases where you have just one database management system, that might be a problem handling terabytes. So you have clusters of them. You have clusters of database servers working together. Another thing that a database management system handles is the APIs and the query languages. And a query language is something that is useful for you who are going to use it as a software programmer. The query language lets you make a question and asking for data from the database. So you can ask for the number of persons that have an age over 20 years and lives in Sweden, for instance. Or you can have a query language that is good at creating tables or manipulating the database server itself. And the third thing that you have here is the matter of concurrency. Concurrency is very hard if you don't know how to perform it correctly. Concurrency is the problem where, let's say, two different clients uses the same server at the same time. So one of those two will have access for writing and the other one is blocked because both of them cannot write at the same time, at the same time. So that's concurrency. And the database systems out there are very good at this. You don't have to worry about it. The only thing you have to worry about is creating the database itself. So that's the thing here. The database, that's the set of data. And the database is managed by the database management system. So a database management system might have several databases. It's quite unusual that it just has one database. It usually have a lot of them. So if you are a creator of database systems, you know that you don't have to worry about that. The only thing you have to worry about is your logical model. That's the problem, your logical model. So it also says here that it's quite confusing more than often than not that the database is used to mean the database management system, the DBMS, and that's true. So most people talk about the database when they really mean the DBMS instead. And that's probably because it's very long. It takes a while to just say the database management system each time, or the DBMS. So it's easier to say just DB. But some of you will be quite skilled at this topic, and they will say DBMS when they need to. So you have the concept of the database management system, and then you have the concept of the database. Those two, they are two different things, but they coexist. And that's the database management system. It sort of allows you to, because I already told you, it allows you to create databases. It allows you to manipulate that database. And by manipulating, I am telling, it could be things like creating a table, or alter the table, or adding rows to it, or deleting, or updating. The DBMS is very good at that, and you will use the query language for that. That's the thing here. That's the query language. Yeah.
The DBMS and the database, are they loosely coupled so you can?
Yeah, sort of. It is possible to do that, but usually you have your database management server having the ownership of their own databases, but you can have one database management server connect to a remote database if you need to. But I think that you should have a good grasp of who is responsible for what here. And also that goes for servers that are duplicated here.
I was thinking more like if MariaDB, for example, is using one kind of database and Postgres is using the same. Or
No. Well, yes, if they have a layer for it, an API that is capable of reading a different kind of database management service data, then it's possible. But I think that most of them just sort of rely on their own database systems. And if you are required to pull data from different kinds of databases, then that's a job for you actually, to create that layer in between. And that's quite a typical task out there. If I may draw yet another screen, picture here. If you have this setup where you have your application, let's see if I can get that to be a bit better. Yeah. You have your application and you will pull data from two different database systems, one from MariaDB and one from Microsoft SQL. Then it's your task to create that layer in between. Much like the internet protocol, that takes different kinds of networks lying beneath it and presents it just like one network. This is the same thing. You have your application, you create your own layer so you can pull data from different sources or push to them. So, but this is more of a software design problem. But it's very common that this is the case. So usually you have an API for that. And then you have your sort of modules for talking to each type of database down there. And this is something that you most likely will do, not in this course, but in other courses you will have, I'm quite sure of it. Yeah, and this is one of those questions. Why not files and file systems? Well, if you try to create your own database file, you will end up with a file system or a file format that will vary and will be very hard to manage. And that's a kind of a flat file system. But if you have a look at the sort of a database source for, let's say, Microsoft's SQL Server, it's just a file. It's a big one. But it has its own format and is controlled by Microsoft. But let's assume that you have your own file. And we will see a few more pictures of this later on. That's just a file. It could be a text file, something that is named myfile.txt. Well, then if you just randomly write data into it, then you won't be able to pull data from it because you don't know the format. And that's one of the problems. Another one that you have here is that with concurrency, let's assume that you have another application using the same file. Well, then you rely on the file system of the operating system instead, which might or might not be efficient enough. So this is the way you do it when you create your own database. And some of you who have studied Java, for instance, or PHP, or some of the other ones, might have created a file, written something to it, and closed it. That's the way to do it. That's a flat file system. And that's an example. And if you have done this before, let's see if we can see it on the live stream. No? Okay, sorry about that. This is just a flat file system, and you might know it as that thing that Excel exports to, CSV or any of the other export formats. And what you are relying on here is that the data is not changed by one of your friends switching the author and the type suddenly or reading it backwards. And also, if you are having a really, really big file here, it might be very inefficient to sort of look for a specific author here. If that file contains 2 million rows, it might take a while for you to find that specific author with specific properties. So if you have ever heard about abstract data types, like trees or lists, if you're talking about trees, you're suddenly talking about indexing and sorting that tree so it will be faster to search in. That's one of those problems that the database management server fixes for you. You should just instruct it to do it every once in a while. This is something that you can do if you want to, and many people do. If you are creating a system or an application where your application is the only user of that file, then you might do it this way. There will be no concurrency problems here. But if you're creating your own server where you have clients connecting to your server, then this might be a problem if you don't do it right. So this is a typical question. How many publications does person X have? Well, then you have to create a code for it. And this is not SQL. So this is a typical question that you will answer when you have that flat file thing. Well, you have to read the rows. First of all, you have to find the file. Then you need to start reading each row and split it by that semicolon. And then you need to check whether that value having index 0 is equal to X. In that case, you will add something. So if we go back, if by mistake I'm starting to switch the first and second column, then we have disrupted the entire file. So this one might be the fastest one for you to create, but it might not be the safest one. But if this is what you need, well, then do it. All right? I mean, if you have a database server here, then the problem of finding the correct table is not the problem, because if someone has actually removed it, you are in deep trouble. But you will be notified, and the database will fix this for you. And this thing, when you are traversing row by row, that's done by the database management server for you as well. You don't need to do it. You just have to ask for it. I need the ones that has that X in the first column, which was the author. And the same goes with that one. So you have both the person named X, and it has the books, or the book named the book. So the same thing, once again, you have to open it, and then row by row starting to check it. Is it X and its book? Then you start to count it. And this is also something that is fixed for you easier, a lot more easier with that SQL language, that query language I was talking about. And this might sound a bit strange, but it's not. So, and everything has a start, and that's it. This is the one. Typically, they started off with the earlier ones having airline reservations. Banking, so is a typical database user. You perhaps have heard about the language COBOL, which is typical of banking language back in the days, or at least administration. And they have those file systems and those flat files created for themselves. And back then they were mostly networks or hierarchicals. And in a hierarchical type of database is a tree, and the other one, the network, is a graph. And you usually don't see these anymore, because there was something else called the relational database management systems that were created a few years later. But just so you know that there are other types of databases here, and some of them are a bit older and are not used anymore. Right? So this is something that you need to also think a lot about, and that is the database model. And this is where you sort of start to think in terms of logical systems here. And I think you might have done this when you were using your, say, let's say Java. You were designing a program. Well, you had to design it first in a logical fashion. Should I use that class in conjunction with that class? Or should I aggregate them in some way? Should that class contain certain properties? Well, the same kind of discussion goes for database modeling as well. You need to have a set of requirements first, so you can create your logical model after that. And usually you have something like this. You have your requirements, and those requirements might be just text, but they will turn into requirements. Then you will have your logical model. And then you will have your physical model, when you sort of turns them into tables, at least mentally. So that goes from your requirements into that logical model. You're finding nouns, for instance. How are those nouns connected to each other, which you might think of as classes if you want to, but don't use that word classes in terms of database modeling. And when you have turned your requirements into your logic model, you're thinking more in terms of tables, which we will talk about later. And when you have your physical model correct, then you create those tables physically into a database. So I think that this is the way you create your programs. You have a set of requirements, you create your design, and then you start programming it, and then you test all that, and then you deploy it, and hopefully it will work. It's the same thing here. So it's a lot more about those data, how they should be stored and organized, and also manipulated. So back to the flat file system. This is what I was talking about just a few minutes ago. It's that comma separated file type. And you by now know that it's a very quick way of doing things, but it might be a bit dangerous because it's very easy for a person to just open it up and start editing, and they do it wrong. Just so, let's assume that I switch Abbas with Ablai, those two, but I keep those data that comes after it. Well, then you suddenly don't know whether those data are correct or not. And those things are better managed by a DBMS. And when it comes to the hierarchical model, we are talking about records and links, and you know this one because I already told you it's that tree thing. And the thing with that tree is that a child can have only one parent, but a parent can have many children. And this is one of the first types of database management systems, and this is the one. And I don't think that it's a surprise for you what a tree is, I hope. And if you don't know what a tree is, think of it as a tree turned upside down. So what is up here is called the root, and these are the children. And when you have no children, then you're a leaf. So if you are adding children, then you sort of just create a new arrow and add your new child just below it. And it's quite easy to do things correct here, but it's also easy to make it a bad thing here, because if I delete maintenance, I will also delete these 3 tables. And if that's correct, well, then it's good. And if it's not correct, then you're in trouble. And this is also another kind of a tree, and you might know it. It's the Explorer, or in this case, the registry editor in a Windows operating system, and it behaves just like a tree. And this is the root. That's the computer, and then you have that root has a few children, and for instance, that local machine store, and that has a few children as well, and then it goes down. So if I, by mistake, would be deleting that local machine storage, then I would delete a lot. I would delete all its children. And I haven't tried it in the registry editor, but I assume that it will prevent me from deleting one of those stores, I hope. And what you have on the right-hand side is properties for that control, or if you want to view it as children as well, well, it depends on your view. And you can have a tree where a child, there's a one-to-one relation between a child and its parent. It's not a problem. And you might have several different children here. And if you have a look at what you have here and compare it to that comma-separated file we looked at just a few minutes ago, this is a bit more order, because what's a child to that publications is the author, and whatever properties that author might have is a child to it. So if that author has been given a bit of money for creating a book or some research project or attending a conference, that's what you will find at its leaf level. So if I am adding more books for that guy, I will add it below that child. This is where I add the books. And if he's a guy that writes articles, then I will add them below that node. And that's the good thing here. There is suddenly some kind of order here, and it's better suited. But there's a problem here. And that is, what if I have an article created by several authors? Yeah, that's it. That's one of the problems with this hierarchical model. It doesn't allow it. So in that case, you suddenly have two different authors having a book node, and under that book or that article, you will have the same article stored twice. And that is also one of those really bad things about this kind of database model. You have duplicates, it becomes redundant. So if you change one of those articles, let's say you edit some part of it, or the storage for it, and you don't change the other occurrence of that article or book, then you have a mismatch. Your integrity has been compromised. You don't know which one is the correct one. And that is quite a common problem. And it's still common when we're talking about those relational database management systems, like MySQL or the one created by Microsoft. You can create that same problem there. Yep.
Will we have a break?
Should we have a break? Yep. How many minutes? 10? I'm pushing 10 right now. Okay. Let's see if we can get this thing started again. Is my sound okay out there? Yeah. Okay. Yeah, and here you have that example which I talked about just a few minutes ago, where you have two different persons having, or actually three persons having done the same thing, have been given the same amount of money, for instance, where you have these three sort of instances. I don't know if that's just the amount of money. Yeah? Yeah, okay, sorry. So what you have here is might not be the amount of money. It might be just an identifier pointing to whatever they have been given. So, but the problem is that there are three of them. So if you change one of them and forget to change the other two, you have that reference problem. And that is bad. That is really bad. And this is typically something that you also do when you have that comma separated file. You add the same thing more than once, and then you change one of them but not the other ones. And to sort of rectify that problem, they came up with that network model instead, which is a graph where you can have multiple children and multiple parents. So, which in this case, you have a parent, two parents pointing at the same child, which is a lot better, because if you change something in that leaf, in that child, both the parents will be sort of updated to the same data. And that's the good thing here. And usually you have a lot of these associations between parents and children, and the other way around as well. But sometimes that presents problem when you are creating your questions for it, your queries. So even though it's good enough, there are better ways for it. And it gets quite entangled after a while, where you can point at anything suddenly. Just create your association and then you're good to go. So sometimes there are just too many combinations here, and that's one of the bad things about that network model. It's easier to create but harder to create good questions for it. So after a while, they came to what is the most common type of database model, the relational model, where you talk about entities and how they relate to each other, and those entities have properties. And this is an older one. It's developed during the 70s. It is quite simple to create tables here. It is quite simple to create models for it. It might not be easy to create those models from an intelligent point of view, but they are there for you to use in a good fashion. And the problem of query a relational database is a lot easier than the other ones, and it's more effective. And even though there are newer types like the NoSQL movement, which has a different kind of view how to store data, even with that it's growing and it's quite good at sometimes, this relational model is the dominant one out there. And whether you should use the relational or the NoSQL one, well, that depends on what you what kind of problem you're solving. So if you're in the industry, you will most likely end up with a relational one. And if perhaps you are creating some kind of web application or on a web server, you might use a NoSQL type instead. It depends. So I am not going to argue or if the other is better than the other one. That will create a flame war in here. And perhaps if we have a bit of time left over at a later time, we can have a discussion about that. But I can start it, and I will probably leave. I'm very good at starting flame wars. Okay. I've used NoSQL databases a couple of times, but they were very good at updating things that went very, very, very quickly. But when it comes to query it for certain data and certain structures, I sort of came into a problem there. So this is a typical table, and those tables have columns, which might be properties, and a table usually has a name, and that table also has a name itself, and it means something. And once again, and I think I mentioned this in my previous lecture, and the same goes here, if you don't know how to name something, then you don't know what you're doing. So stop, reread, or study the problem once again. So, and strangely enough, in this relational database model type, a table is also called a relation, because it's a sort of a relation between things, between entities. And then you associate those things with each others. So, with that said, those are the columns: name, person, and age. And what you have here is a row or a tuple. And a table might consist of many rows. It depends on, let's say, the hard disk size, or if you have it distributed, it might be a bit bigger. But in normal cases, the size of the table is not really a problem, just in general, but just be aware when I say that, it's just in general. In specific cases, you really need to control how much memory you actually need for a table. One thing here is that the order between the rows in a table has no meaning. And that's one of those common mistakes. If you are using the query language, then you sort of expect to get the answer back, or the rows, because that's what you usually are after. You sort of expect that you get the rows back in the same order as it was stored in the table. Well, that's a bad assumption. Even if it usually is that way, you can never assume it that way, because order has no meaning. If you want it to be ordered, then you have to ask for it in your query. Oh, and sometimes I write down tables and their properties or attributes in this way. And let's say the name of that table is ages. Sometimes I write it that way. I just name the table ages and parentheses, and the name of the columns. That's a shorthand I sometimes use because I don't want to just actually draw a table each and every time. So this is my shorthand, and it's called something. I don't remember what it's called, but it's quite useful, because if you have my table, which I will call X, and they have the columns Y and Z, I can sort of compare these two and set them to a relation. So it's easier for me to draw it on paper. That's what I mean here. So instead of doing that thing, I'm doing that instead. Is that okay? Right? Oh yeah. So that's the NoSQL movement, and you have different versions of it. The document, which if I remember correctly here, it's the MongoDB uses the document thing. The object-oriented version was something that was really hot in the mid-90s. It was because in the mid-90s object orientation was growing really fast, so they thought that, okay, even if our programming model is object-oriented, why cannot our database models be object-oriented as well? Well, that didn't happen because it turned out to be really difficult. But it still exists. So we're turning into the final slides here. So let's have a look at once again that persistent storage, which a management system is really good at, and that is something that you don't have to worry about. Let's assume that you need a backup for it. Well, if you order the management system to back it up for you, it will be done, and that is a very good thing. If you don't know what a backup is, please have a look at internet. It will probably save your life at some point here. If you by mistake erase your database, which is a file, you can actually get it back. So at first you will be a person that many don't like, and suddenly you're a hero when you get it back. Yeah.
You said that in Microsoft SQL that they store it just as a file.
Yeah.
Can you just copy the file?
Yep. That is one of the ways of doing it, and that's the copy the MDF file and store it elsewhere. However, usually it's locked by the database management system, so you have to turn the server off first before you copy it. So it's easier to create a backup because that's also a file, and order it to be placed in a different directory. And that backup file is something that you take on your USB stick and import it back into your development computer or development database.
And then you export it from the DBMS.
Yeah. It's really easy. It's really easy. That's something that we use very frequently. If you're creating a software system and the data you're using is old, it might present a problem, so you want to have the latest version of that database. So you ask for a backup, then you take that backup and restore it back into your own computer instead. Then you have a fresh set of data to work with. Yeah, and we talked about that API and the query languages, and then you know that that API is something that you probably will do at a certain point if you have different kinds of databases that are not able to talk to each other. So you are layering in your software in between. And we also had that discussion about the concurrency here, and the concurrency is a real problem. And that is solved by the database server as well, because you cannot, if we go back to that one, if we are two clients trying to update the age of Alice at the same time, it is a problem. So the server has to first allow the first client to start writing and blocking the other one. So they will not be written over at the same point, which is bad. And there are the other versions of this where you allow one client to write, then you allow multiple clients to read instead. And I don't know if you will be taught anything about this. I was taught about that when I was studying operating systems, which is a few years back. But I rely heavily on it when I'm creating my own multi-threaded systems. Because if you're creating your own threaded systems, you are very aware of the problems of these things. You can have a look at the concept of deadlock, for instance. So this is the first one. This is actually one of the first things I drew on the whiteboard. You have 3 different applications, or it might just be the same instantiated 3 times, and then you have to go 3 files. So each application reads and writes from the same file. The problem here becomes when application 1 needs to get something from data file 2, and data file 2 has a different type or a different format than what it is expecting. So what application 1 has to do is to create some kind of self-layering so it can access data file 2. And while that person is doing that, the person creating application 2 changes the format, and then you're back to square one again. So I hope you can see the problem here with that format thing. It's really a problem here, and it becomes that when you are letting your application loose in the jungle there. As long as you're on your own, sitting inside your own room and doing things, it's just fine. But let it loose and see what happens. So this is the picture I drew a while ago, where you have, which is called generalized access methods, which is just a layering thing. You put a layer between your application and your data files. So I might be the application number 1 creator, and some of you in here will be that layer creator. So what I'm doing is that I am importing your code into my code and start using it. Or if you are giving me access through internet, I might use a TCP protocol to connect to your server to get access to the data. Depending on your strategy, things might go good or not. And I really have to say this. It's really hard to create those layered applications. It's easy to create them, but it's hard to maintain them. That's what I was supposed to say. Because when things get bad beneath, and you have to make changes here in the API going upwards, then you're usually you are sort of in a trouble. Because if these applications are already running on a site, then they need to stop what they are doing, update their software to follow your changes. So it's really easy to talk about this, but to do it is really hard. And some people really like to just draw a square in the middle and let's call it the generalized access methods. It should just be done. That's when it starts. So this is sort of a next step. Then you have your DBMS in the middle, and then you have your databases below. And this is the way things works these days in at least most cases. So I hope you can sort of see the evolution from those flat files and that layer over to this DBMS. And also, and I didn't talk that much about it, but it says here, logical data model, physical data independence. Well, your logical model, that's the analysis and design. That's something that exists inside your heads. How you implement that might be really different. Let's assume that I have created I shouldn't have raised that. I might take that logical ages table and I might implement it on either a MySQL server or a MS SQL server or any other kind of relational database. So my logical model holds, it's correct, but I can implement it anywhere I like. And that's a good thing. And sometimes you also need to sort of export it from, let's say, MySQL, export it from that and import it into a Microsoft SQL, or I assume most people in here prefer it the other way around. But it doesn't matter if you don't get your logical model correct here, then it doesn't matter whether you sort of implement it on the MySQL or the Microsoft SQL server. So the logical model needs to be correct. Oh, query languages. Here we are, safety also. The recovery and the security thing. And we also have one other thing that we haven't been talking about at all, and that is the authorization. The user topic. Are we letting anyone into our database, or should we prevent people from getting into it, or preventing users? Well, that's also a thing that a database management system is really, really good at. So we might give access to a certain type of users to read from a table, and the other ones just to write to the table. And some of them might be given this both double access, both read and write. So perhaps you also get it why there are sometimes database experts here, which are really, really good at optimizing a specific type of databases or a specific type of database, like a MySQL or MySQL database. They might be an expert in that, how to configure it, optimize it for a specific usage. I am not one of those guys. I'm one of those guys who creates those logical models over to the physical ones, implements it, and hopes for the best. All right, questions? So let's just briefly go back to that first. To that slide where we are at the 7th of November today. So the next one will be on the 13th. If you want to attend physically here, then it's fine by me. If not, well, then you can have a look at it afterwards because it will be recorded. All right? Okay, thank you for today.